Tesla is preparing something for 2026 that makes every milestone in its history look like a warm-up act. The plans unfolding inside the company's factories and research centers are so massive that even industry analysts are struggling to believe the numbers being hinted at. What is coming is not just about more electric cars rolling off production lines, but about rewriting how energy is made, stored, and consumed on a global scale. This isn't a small step forward, it is a transformation of the very foundation of Tesla's business and the wider EV market. And right now, you're about to discover what Elon Musk has been carefully building, why it changes everything, and how it could shape your own future in ways you might not expect. Before we go deeper, make sure you're subscribed with notifications turned on, because the details we're about to explore are not being openly discussed anywhere else, and they reveal just how far Tesla is really prepared to go. One of the most shocking revelations is that Tesla is quietly moving toward producing 500 battery cells every single second. That number sounds like science fiction, yet the groundwork for it is already being laid. Down in Texas, near Corpus Christi, the company's new lithium refinery has gone from blueprints to operation at a pace that few thought possible. Within only 18 months of breaking ground, the giant kiln at the center of the refinery has already been fired up and has processed its first batch of spodumene. This is a milestone that normally takes years to reach, yet Tesla is sprinting ahead, fueled by a refining process that looks nothing like the industry norm. Instead of using harsh, acid-heavy techniques, the company is leaning on an environmentally friendly method that uses table salt and water. It is cheaper, cleaner, and capable of scaling in ways that could supply enough lithium for 1 million cars per year once the site reaches full production. But raw material refining is only one piece of the story. On the other end of the production line, Tesla's battery engineering team has been perfecting its 4,680 cell design. First revealed at Battery Day in 2020, the 4,680 promised more energy density, lower resistance thanks to its tableless design, and production costs low enough to make the long-promised $25,000 Tesla a reality. However, the challenge wasn't in the design but in scaling it. The dry-electrode process Tesla pioneered was plagued by bottlenecks, uneven coating, and poor yields when pushed to mass production. Critics doubted it could ever be industrialized. Fast forward to today, and those doubts are vanishing. The Gen 2 4680 is lighter, stronger, and Tesla has finally cracked the code on dry-electrode manufacturing at scale. This breakthrough, combined with clean lithium from Corpus Christi, means Tesla can finally hit the breathtaking pace of 536 cells per second. This kind of scale matters more than most realize. Tesla's older models ran on smaller 18,650 and 2,170 cells, which served their purpose but limited how far costs could fall. The 4680 changes that equation, delivering performance and affordability together. But batteries aren't just for cars. Tesla's energy division is growing fast, with Powerwalls for homes and megapacks for utilities quickly becoming as important as vehicles themselves. Gigafactory Nevada and the Megapack facility in Lathrop, California, are cornerstones of this effort. At the same time, Tesla is increasing its reliance on lithium iron phosphate, LFP, chemistry. While less energy-dense than nickel-based chemistries, LFP packs last longer, cost less, and are perfect for affordable EVs and grid-scale storage. Meanwhile, Tesla is also tracking solid-state research, waiting for the moment the technology is ready to leap into commercial production. All of this is only possible because Tesla is securing its supply chain like no other automaker. Most car companies depend entirely on suppliers for lithium, nickel, cobalt, and graphite. Tesla has chosen vertical integration, pulling refining into its own hands. Once the raw materials are processed, the company's cylindrical cells are assembled, tested, and built directly into packs. Tesla has even skipped the traditional module stage with its cell-to-pack approach, reducing cost and weight while improving energy density. This relentless drive for efficiency explains why the numbers add up so quickly. In 2024 alone, Tesla sold 1.78 million vehicles. That required close to 7 billion cells, with each car demanding anywhere from 1,300 to over 7,000 cells depending on model. And that doesn't even account for energy storage. Powerwalls and megapacks could push demand for batteries to 10 billion cells annually, surpassing the EV business itself. To meet this demand, Tesla balances partnerships with independents. Panasonic, LG Energy Solution, CATL, and BYD are all crucial players. BYD's Blade batteries, in particular, are a fascinating twist, since the Chinese company is both a partner and one of Tesla's fiercest rivals. It's a situation reminiscent of Apple and Samsung in the smartphone industry, competing at the highest levels while relying on each other in supply chains. BYD's lithium iron phosphate packs are already used in standard-range Teslas in China, accounting for nearly 40% of supply. Tesla has been testing them in the US as well, paving the way for cheaper, more durable models worldwide. But at the same time, Tesla is moving quickly toward independence with its own 4,680 cells. Having already produced over 100 million of them, Tesla is expanding Nevada to reach 100 gigawatt-hours per year, enough for over 1.5 million cars. Still, no single strategy is enough, and so Tesla continues to draw from multiple partners while accelerating its own breakthroughs. The progress at the Texas lithium refinery shows how serious Tesla is about securing the future. Drone photos reveal foundations for multiple production lines, power substations coming online, and the massive rotating kiln already running. Jobs are being filled for metallurgists, managers, and logistics experts as Tesla prepares to scale this facility into one of the largest of its kind outside Asia. Once fully ramped, the site will feed directly into Tesla's battery factories, providing the backbone for the company's aggressive 2026 goals. The implications are huge. If Tesla can control its own lithium pipeline, it not only shields itself from price shocks and shortages but also gains the power to drive costs down in a way no competitor can easily match. At the same time, Tesla and the broader industry are pushing battery technology forward in three key directions: faster charging, higher energy density, and longer life. Tesla's next-generation superchargers are already hitting 500 kilowatts, letting vehicles like the Cybertruck recharge at lightning speeds. Across the industry, companies are working toward charging rates above 350 kilowatts, cutting wait times to under 15 minutes. On the density side, Tesla is developing chemistries that can pack more range into the same space or reduce vehicle weight while keeping range constant. And when it comes to lifespan, the focus is shifting from hundreds of thousands of miles to the goal of million-mile batteries, packs that can last longer than the car itself. Battery recycling is becoming equally critical. With billions of cells being produced annually, waste is not an option. Tesla has pledged to recycle 100% of its used cells, while companies like Redwood Materials and Li-Cycle are developing methods to reclaim lithium, nickel, and cobalt for reuse. This circular approach could help solve both supply chain and environmental challenges at once. And Tesla isn't alone in building refining capacity. Stardust Power has begun constructing a $1.2 billion lithium refinery in Oklahoma, designed to produce 50,000 tons annually. Located strategically near shipping routes, it demonstrates that America as a whole is racing to bring battery production back home. But Tesla's head start, speed, and innovation give it an edge that few others can match. So where does all this leave us? The scale of what Tesla is building, refineries that can outpace Asia, batteries that can be produced by the hundreds every second, and charging speeds that rival gasoline, signals a future where electric mobility and energy storage are not limited luxuries but standard realities. For consumers, it means cheaper cars, faster deliveries, and more reliable access to clean power at home. For Tesla, it means cementing its position not just as an automaker but as the foundation of the new energy economy. If what we've seen so far in Corpus Christi and in 4680 scaling has left you stunned, just wait. The next wave of developments, including new chemistries like aluminum-ion batteries, will only add more fuel to the fire. Musk and his team are rewriting the playbook, and the chapters still to come could change the way we all live.